सो इनवर्स काइनेमेटिक्स। तो क्वेश्चन ये था कि ये तो चलो हमने अपनी मर्जी से सेट कर लिए, हम चाहते हैं कि आर्म इस जगह पे पहुंच जाए। अब देखें, ये मेरी डिजायर्ड पोज है। पोज मीन ये पोजीशन मैं चाहता हूं कि आर्म यहां पे हो एंड इफेक्टिव, और उसकी ये ओरिएंटेशन, और ये कुछ भी हो सकता है, मैं यहां से चेंज कर सकता हूं। मैं यहां से चेंज कर सकता हूं। लेट्स आई मेक इट 6, ठीक है, या मेक इट 4। तो आप देखें, जब मैं यहां से डिजायर्ड वैल्यू दे रहा हूं तो उधर थीटास पे नजर रख लें, 6 थीटास चेंज हो रही हैं, क्योंकि मैं वो, अब ये वो रिवर्स प्रॉब्लम है। उधर हम ये चेंज देते थे इनपुट इनटू द सिस्टम और हमें ये मिलता था, इसको फॉरवर्ड काइनेमैटिक्स कहते हैं। लेकिन रियल वर्ल्ड में तो ये नहीं है ना कि मैंने किसी जगह पे पहुंचना है तो मुझे थीटास का डायरेक्ट पता हो कि ये थीटा होने चाहिए। हम ऐसा तो नहीं करते। हम इस बंदे को लोकेट करते हैं, अपनी मर्जी की जगह पे पहुंचाते हैं। जैसे कि वेल्ड करना है, कोई हमने असेंबली, कोई चीज उठानी है, कोई चीज कहीं उठा के रखनी है, तो दिस इज व्हाट वी गिव टू द सिस्टम, और अकॉर्डिंगली ओरिएंटेशन भी अपनी मर्जी का सेट करते हैं, फिर जाके हम थीटास निकालते हैं। So if this side is given and you are to find these theta's, कि भाई इस पर्टिकुलर पोज में इसको डालने के लिए थीटास की वैल्यू क्या होनी चाहिए, क्योंकि थीटास की वैल्यूज आप समझें, अगर आपको पता चल जाए तो आप हर जॉइंट पे जो मोटर है, डीसी मोटर, उसको कह देंगे कि इतने डिग्रीज घूम जाए। पहले वाले को कहेंगे कि 24 डिग्रीज घूम जाए, सेकंड वाले को कहेंगे -52 डिग्रीज रोटेट करें, and so on. You will instruct each joint to rotate by those many degrees. So given the pose and finding the thetas, this is called inverse kinematics problem. जब ये प्रोवाइड करते हैं और आपको थीटास निकालने हैं तो ये, और फॉरवर्ड काइनेमैटिक्स ये कि गिवन थीटास व्हाट इज द एंड इफेक्टिव पोज। सो अभी हम so given, if you look at this, what is given? We are given this is given. And the factor or tools, position and orientation of the tool frame, or the tool, or on the end effect. Okay? Normally it is your last frame. So for example, if this if it is a 6 degrees of freedom arm, then x6, y6, and z6. So if you recall, if this is your robot and the vector, like this is the gripper, then normally here we place this, right? We call this z6, and then we call this one y6, a sliding vector, and then this is your y. So x, right, x is towards you, out of the page, according to the right hand rule. So this, we don't know how many links are there and how well we know how many links in this particular example, because the last one is 6, so if we start it from 0, so it's a 6 degrees of freedom. But we don't know where the joints are, what are the lengths. All we know that there is somewhere this x0, y0. This is normally, let's say this is z0, and that is why it should be into the group. Okay, but we somehow know that the arm has positioned itself to reach there. Let's say these are the angles, or these are the angles. We don't know how the angles are. how the arm has positioned itself to give you that particular form. Okay, and what is required? The setup theta, the setup. Or the values of joint variables that gives the given pose, or that puts the arm in the given posing position and orientation. And now in terms of numbers, this position is normally, it's a 3 by 1 vector. We call it the position of the origin of this ring. We call that position vector P. We normally write origin of X and whatever, but anyway, it has an X component, it has a Y component, and it has a Z component. This is normally 3 by 1 vector because we're in the 3D. And this orientation is usually given as a 3 by 3 vector, rotation matrix. So R33, R33, R31, R32, R33. This is a 3 by 3 matrix. So these numbers are given. Exact values, numerical values are given. And now we have to solve for what? We have to solve for thetas. Or we say we have to solve for Q's. Q1, Q2, all the way to Q6 or Q8. N is the number for Q8. So what are those? If you have all the joints are ribbable, in most of the cases they are, then Q's are simply thetas. Theta 1, theta 2, all the way to theta n. Here n is the number of joints, number of degrees of freedom or joints. So this is what the problem we're going to solve. We are given a certain indefective pose, and imagine if you have to follow a certain line. Let's say we want the indefective to follow this line, but while at the beginning at t is equal to 0, it is in this particular orientation, this particular position. But at t is equal to, let's say, 10 seconds, it's in this particular orientation, in this particular position. While on the way back, definitely it has to go, so you have two options. It goes like this, slightly moves, and then it reaches there. It just all of a sudden, it was here, and it all of a sudden rotates and gives that particular orientation. That's one option. Second option is right in the beginning, just turn, achieve that desired orientation. For example, just from here, achieve that desired orientation, and then slide along this to reach that desired position. This is also fun. Another possibility is that while you move, you know that you have to reach here. So what you do is you slightly, while changing position, you slightly make your, you bring a change in orientation. So in other words, what we normally know, is that on every point, if you see here, the position has changed and the orientation has changed. So this is one set of that desired P. P6 and 0. Because P6 and 0 has both the position and orientation. The orientation is in the form of a matrix. And then at the other time instant, we have another one. And then we have another one. And at every point, we find these thetas. the joint angles. And then we ask the arm to achieve that particular pose by just rotating by those many degrees, because we now know the thetas, the joint variables, and then we ask the arm to just move in that particular position. And then we just move a little further, and then we have another indefector position and orientation, and then we solve. This is the inverse kinematics problem, and then we solve for the thetas again, and then we get a new set of theta, and then we move on. So while the robot arm is moving from a starting pose to a desired pose, on every time step, let's say this time step was t is equal to 0, maybe this is t is equal to 0.1 second, and maybe this is t is equal to 0.2 seconds, and so on. So at every time, these are, you can also call samples. While you move from a starting location to the end location, at every time instant you are given, because when we plan the path of the robot, or when we plan the trajectory, the way the arm will go from the start to end, we give it a certain, we define the problem in terms of in the vector tool. Because, for example, we say that when you're here in this particular starting pose, grab some bottle or grab some object, and then when you reach at this particular point, and you go in the straight line, then you just go and turn that bottle around and just place it there. So it could be any object, or it could be welding, or it could be any other application in the industry. Sometimes the path that you take while going from start to end, it has to be a certain path. For example, in this case, it was a straight line. But in other cases, we might not be restricted by the shape of the path between the two desired points. You could go that way and reach here. You could go anywhere and reach there. So that kind of motion is called point-to-point motion, where we go from one point to another point, and we don't care for the pose that the arm takes while in between. And sometimes we want to restrict it a certain path. Oh, it might be a circle, it might be a circular arc, it might be a straight line, or it might be any complex path. So we'll see that in the trajectory planning or trajectory generation or path planning chapter. But right now, I've defined the problem, that what the inverse kinematic problem does. It takes a given pose and it solves for these unknown thetas. It is exactly the opposite of what we did in the forward kinematic case, where the theta values were given and we need to find the end effector pose and orientation. Okay, let's move on. So last time I defined what is a reachable workspace and what is a dextrous workspace. So reachable workspace is all the points that this arm can reach. For example, if you change these theta 1 and theta 2, this could be another pose of the arm. Could be another, and even you go along. So everywhere you go, you just have this point. So if you take the trace of all these points in this case the plane, but normally it's in the space. Okay, so if you combine all those points together, so the set of those points, we stretched out. Okay, it's that theta 1 is always 0. So you just keep this angle is theta 2 is 0, but you just keep on changing theta 1. So you can have this on here. You can have it here. So if you can notice, you are completely making a circle here. Can you make a circle when the both arms are stretched out, when theta 2 is 0? Okay. And similarly, if you make theta to 180 degrees, then this arm will be just like there, and it will come back and it will just position itself that way. at the at the origin. And then if the two lengths are equal, I'll give you the different shapes on a separate slide. And what are the possibilities that if the two lengths are equal, then what is the reachable workspace? If L1 is greater than L2, then what is the reachable workspace? If L1 is less than L2, then what is the reachable workspace? But what the workspace is the set of points. It could be spherical, it could be planar, it could take any shape. Okay, so different robot geometries are famous. I'll be providing solution to homework 1, and then you can see the common robots and their workspace. What is a dextrous workspace? A dextrous workspace, it's a workspace in which the benefactor can achieve any orientation. Any orientation. For example, you might notice in some robotic arms that you can reach a certain place, but you cannot reach there in any orientation. For example, think of the example of your arm. If I ask you to hold a glass or an object in any orientation in front of your face, just right close to your chest, that's where we normally keep things comfortably. So you can keep the bottle upside down, you can keep it straight up, you can give it any angle. पानी let's say आपने डालना है glass से jug से glass में, so you can do it very comfortably. But if I ask you to do the same thing while holding your bag, what you're trying to do is here, theta 2 is 0, so you can reach here. And while you reach there, if you give the theta to a certain span, let's say theta 2 could be this, and it's all the way, you can go there, and theta 2 could be that. So while you keep theta 1 constant, and this theta 2 takes these values from here to here, so that it can give your arm this particular, you can reach this particular workspace. This is your reachable workspace. Okay, and similarly, if you go all the way to this end, and then give it a full span from here to here, okay, then that is also that also. And if you trace those dots, you can form a workspace. Okay. And if you look at the left side, we have two joints in this case. We have two joints in this case. So let's say we have Q1 and Q2. So what Q1 can take on a value is Q1 is theta 1. So it has a minimum value and it has a maximum value. Ideally, you would expect a joint to have a minimum value of 0 and a maximum value of 360. But in reality, practically no arm can easily achieve a 360 degrees of motion. There are always restrictions. Even our arm, if you look at your arm, not all joints, if you look at your elbow, it cannot achieve a 360 degrees rotation. Maximum, I think it can it cannot even achieve 180 degrees fully stretched out and then folded. So every arm has a certain range of motion that it can achieve. So there is always a theta minimum and there is a theta maximum. So let's say for this particular arm, which only have 2 degrees of freedom, we have one axis Q1, which has a minimum value here. Let's call that point A. And then we have this maximum, let's call that point B. And similarly, for the second joint variable, we have this minimum, Q2 minimum and Q2 maximum. And definitely there a point comes where both the Q1 and Q2 are 0. Okay, so if you plot on this particular plot all the dots, all the possible dots, where let's say Q1 is 1 degree and Q2 is 0, Q2 is Q1 is 2 degrees, Q2 is 0, and then so on. So all these points, these are now this rectangular shape. This is now your reachable workspace. These are all the possible combinations of joint variables. Anyway, that was about the workspace. in last lecture I explained this, that uh, let's say this is given for a certain robotic arm. It is for the Stanford manipulator. We saw the example of its power kinematics. And then the numerical values are given. This is the indifactor orientation as a, given in the form of rotation metrics. And then this is the position of the origin of the footprint. And then what we are going to do is we know that we have reached here through these equations, so we know those equations. But what we don't know in those equations is the exact values of those thetas that when plugged in, they can give us these numerical values. So what we do is we take the expression for R11. It's a lengthy expression. It's a function of almost all the thetas except theta 2. And then we equate it to that element. And we're trying to solve for these unknown thetas. So all you see is the cos or sine of those thetas or their product, but it's very hard to solve for those thetas. Similarly, R12, we equate it to 1, and R12 is here. We equate it to 1 and we solve for this. The problem with solving, okay, so how many equations you have got? If you equate everything on the left to everything on the right, so you have these 9 equations will come from here, 3 from here, so 12 equations. And what we are solving for is 6 thetas, okay, 6 thetas. So we might be able to solve it through algebra, but the problem is these equations are not linear. If they're not linear, then no algebraic rule that we're doing today will not apply in there. So definitely the problem is not as simple as it seems. And then you cannot just take theta 1 and take everything to the right side and solve for theta 1. No, these are coupled. You might not be able to separate one theta on the left and leave all the theta on the right. It will not be that easy. Okay, so Samad, I don't know, आपके साथ मसला है या बाकियों के साथ भी मसला है. If anyone who cannot listen me properly, please raise your hand. Anyone who cannot listen me properly, please raise your hand. मेरे end पे तो Wi-Fi signal is good. So Kashif, for example, you're given what you are given is, let's say 2x plus 5 equal to 0. Then the closed form solution is if you leave x on the left and take everything to the right. Okay, so that's your closed form solution. And another example is even if there is y here, so we can separate, we can solve for any variable and we can write it in terms of the other. Okay, but similarly, there are 6 thetas, so you might not be able to leave one theta on the left and take everything to the right. These equations are too complex to do that. Okay, so the equation to solve are in general nonlinear, and thus it is not always possible to find a closed form solution. Okay, you can do this with linear equations. Linear equations are those which do not involve any squares, which do not involve any sine or cosine thetas or their product. Linear equation is just these kind of equations where the coefficients you can change and then you can just simply do these kind of operations. Okay, sometimes there might be solution, but there might be multiple solutions. For example, if you look at this particular arm, so if let's say this was your desired, this was the given indifactor position and orientation. So this is the theta 1 value. Roughly we can say it is, let's say, 30 degrees. Visually I can tell. And this is, let's say, you can say 45 degrees. So you have solved the inverse kinematic problem to get that particular pose. But this was also possible. This pose was also possible with this particular these two values of thetas, where theta 1 value would be that and theta 2 value would be negative. Okay, you're still getting that same pose. So in that case, we have two solutions which are given, two set of thetas. For example, this theta 1 might be 60 degrees. Looks like 60 degrees. And theta 2 is now, let's say, minus 45 degrees. So now you have two set of equation. One is theta, one is 30 degrees and 45 degrees in order to get that same pose. And what the other one is 60 degrees and minus 45 degrees. Both, if you plug in the forward kinematic equations, they will give you this same pose, position in orientation. So multiple solution might exist, okay, which is not desirable. So it would have been good if there was just one unique solution. So how to deal with that, we'll see. And there might be infinite solutions. For example, there might be infinite in case of a kinematically redundant manipulator. Okay, so and there might be some solutions which are not admissible. They're coming from the math, but they physically, practically, they're not possible. All right. So how to solve inverse kinematic problems? So there are three techniques, in fact. One is algebraic way of solving the inverse kinematic problem. Solving for those thetas algebraically. And then another is finding those thetas geometrically. We'll see these two examples today. And then there's a third one, which is called numerical technique, which are other than these two. So right now we cannot cover numerical techniques unless we cover something called Jacobian in our future lectures. But we can have examples on algebraic and geometric techniques. So let's say this is an arm given. It's a 3 degrees of freedom arm. So we have this is the link length of the first link, A1. A2 is the second link. A3 is the third link. Meeting is finishing in less than 1 minute, so inshallah we'll come back right after, and then I'll start from this point onward. Okay, so so this is the forward kinematic model of this arm. DH table is easy to derive if the arm is given. Okay, but here we're given this, we're trying to solve for the thetas, three thetas, theta 1, theta 2, and theta 3. This is px from here to here, and py is from here to here, and this is known. The numbers are known. And similarly, in the vector orientation, it can only achieve orientation about z-axis. It can only rotate about z-axis. So in the vector arm can be like this. It can be like this. It can be like this, or it can be like this. So all it does is it is just rotating about. So this, for example, this one is, it has been rotated 90 degrees about z. So let's say it rotates 90 degrees about z, so you'll get this. Further 90 degrees about z, so you'll get this. No, sorry, 180 degrees, then you will get this. And from here, if you want to go there, then by minus 90 clockwise by 90 degrees, and you will get this. And you can achieve any orientation, but it will be only about z because it's a planar arm. Okay, so the value of alpha, the value of phi, it might be given anywhere between 0 to 360. Let's say our arm can rotate 360 degrees, and there are no joint limits. Okay, and the other two numbers, they are also, they're in meters. So what we are going to do is we're going to solve for theta 1, theta 2, and theta 3. From this matrix, I can see what are the unknowns. They are the three thetas. A1 is known from the DH table. These are link length. They are given. A2 is given and A3 is given. The only thing that is not known is the value of theta 1, theta 2, and theta 3. So how to solve for it? So there is one algebraic way of doing it. Okay. So given is in the vector orientation phi, all we know is it's the sum of the three thetas, because all three thetas are about z axis. So theta 1 is about z naught, theta 2 is about z1, theta 3 is about z2. So when they're all about the parallel axes, we can simply add them, and when you add them you get phi. So we know that phi is just the sum of these three thetas. Okay, but simply we cannot solve it right away because these are three unknowns and this is just one known. Okay, and similarly px we can pick from here, position of the origin of the tool frame along x, this one. So it is equal to a1 cos theta 1, a2 cos theta 1 plus theta 2, and a3 cos theta 1 plus theta 2 plus theta 3. Okay, so we can simplify a little bit. How? We know that if the coordinates of this point are given, okay, we know that the coordinates of this point are px and py. Okay, this is px and this is py. So what we can do is we know that a3 is known. So if a3 is known, what I can do is I can compute this distance to be, how much is this? If you look at A3, if you look at this triangle, this one, this, and this. Okay. So what is it equal to? What is it equal to? Not that one. If you look at, yeah, this one, then this theta, what is this theta equal to? Who will I ask? चलो जरा माइक भी चेक हो जाए. फैसल जमील, Faisal, can you hear me? Hello? Hello? Faisal, can you hear me? That's right. Okay. I'll ask the next guy, Abbas Yusuf.
Yes, sir.
Abbas Yusuf, what is this angle equal to in terms of theta 1, theta 2, and theta 3?
So, sir, perpendicular by base.
No, this theta. What is this angle equal to? Sorry, not theta, but just this angle. See, is this arm
Theta 1
has...
plus theta 2 plus theta 3.
Sorry, say again.
Theta 1 plus theta 2 plus theta 3.
Good, very good. Because if you look at this theta 1, okay, so if you look at theta 1, it was this, and then that's where the second theta starts from. This was theta 1, and this is theta 2, and when you reach there, let's say that is your theta 3. Okay. So phi is equal to theta 1 plus theta 2 plus theta 3. Okay, so if you look here now, if you from that triangle, this distance will be equal to A3 because the hypotenuse is A3. It will be cos of theta 1 plus theta 2 plus theta 3. Okay? And similarly, what this distance will be equal to? It will be equal to just opposite of that, the perpendicular. That will be equal to A3 sine of theta 1 plus theta 2 plus theta 3. In other words, A3 sine phi. And this one is A3 cos phi. Okay, so that means your PWX, this point, PWX is just PX minus A3 sine phi. देखो ना, ये distance subtract करें from PX से, so you will be left with this distance. This is your PWY. And similarly, PWX, this distance from here to here, PWX is PX minus A3 cos phi. So now, इसका फायदा हमें क्या हुआ? What we are getting out of this? If we can find PWX, this position of this origin was given, but through some trigonometry we reached here. So if this point is known, because P is known, the numerical value of this is known. This is known. The numerical value of this. So it means you can find this distance. If this distance is known, why not to subtract this from the px which is known and get this? इसका फायदा आपको ये हो जाएगा कि pxy को, this point is only a function of theta 1 and theta 2. So you have reduced dependency on one of the thetas, theta 3. Okay. So instead of knowing this point and solving for 3 unknowns, now we know the position of another point and we can solve for 2 thetas. That's easier than solving for 3 thetas simultaneously. Okay, so we have redefined the given problem. So we say that PWX is now the difference between the PX minus A3 cos phi. Okay, and PWY similarly is the difference between PY and A3 sine phi. And now we will equate that to what is given. We'll equate that to what is given. So what was given initially was Px was equal to A1 cos of 1 plus A2 is this thing. This is equal to Px. A2 cos of theta 1, 2 plus A3 cos of 1, 2, 3. Cos of 1, 2, 3 means cos of theta 1 plus theta 2 plus theta 3, which also means cos of phi. Okay. So now if I write Px minus A3 cos of 1, 2, 3, this is equal to A1 cos 1 plus A2 cos 1. And this thing is equal to PWX. So we have simplified what was given, plus A2 plus A2 cos of theta. And similarly, PXY. PXY is equal to A1 sine theta 1, A2 sine theta 1 plus theta 2. Now, what we can do is we need to solve for theta 1, theta 2, and theta 3. How many equations are given? 3. One equation, second equation, and third equation. And they're not linearly dependent. So we should be able to solve for three unknowns now. So how? First of all, take this. Okay, it becomes all messy, so I delete this. Okay. Delete this one. This one. So now we are solving for the three thetas. Okay. So first of all, look at the triangle O0, O1. This is the origin of frame 1. This is the origin of frame 1 because this is x1 and that is y1. It looks like theta. Sorry about that. It's O. Okay. And W is this point, the rest point, W. Okay. So look at this triangle, O1, O0, O1, and W. So where is the triangle? The triangle is this one. Okay. So we can apply on that the law of cosines. What is the law of cosines? Law of cosine is that is the law of cosine is if you have if you have a triangle which is not a right angle triangle. Let's say this side is capital A, this is capital B, the length of it, and this is capital C. And the angles opposite is this is small d, this is small a, and this is small c. Okay, so angles are A, B, and C, and lengths are A, B, and C. So you can get any side from B square is A square plus C square minus 2AC cos of the angle opposite to B. Okay. If you look at this, so the law of cosines is, I think we have a plus here. We'll see. Let me just quickly search for it. Okay, so generally, okay. So law of cosine is, sorry, we have minus there. Okay, so it is a c square is the a square plus b square minus 2ab cos of this. So this was right. We were right before. This is negative. Okay, so we have this law of cosine applied on this triangle, the red shaded one. So let's say this is your let's call this what? Let's call this T. Okay. So from the previous slide, T square will be, and this length is A1 square plus A2 square, okay, A2 square, minus 2A1 A2 cos of the angle opposite to capital T, this angle. Okay. So that angle is, let's call it small t from the law of cosines. Now in terms of given, I mean, if we write it as this, a1 square plus a2 square minus 2a1 a2 cos of, and this t is actually 180 minus theta. Look at this. If it was like this would be a 180. So 180, just take out theta 2, so it will be 180 degrees minus theta 2. Okay. And on the other side, if this t squared from this triangle is just equal to py, pwy, and this side is pwx. So it is just equal to pwx squared plus pwy squared, equal to that. And cos of 180 minus pi by 2 is equal to minus pi 180 minus this is equal to minus cos of theta 2. Okay, minus cos of theta 2. So that's why you see the minus sign goes away and you get this expression. Pwx squared plus pwy squared is equal to a1 squared plus a2 squared plus 2a1 a2 cos of theta 2. Now everything in this equation is known except theta 2. Look, this is known, okay, pwx. It was from here, px minus a3 cos of phi. Phi was given, okay, and we solve for theta 2. Just leave cos theta 2 here and take everything to the left side, so you will get this minus a1 squared minus a2 squared and divided by 2a1 a2. So this is, you have solved for theta 2. Okay, theta 2 is just the cos inverse of this whole thing, the cos inverse of this whole thing. Okay, and we know that the maximum value of the cos of an angle can be 1 when the angle is 0, and it could be minus 1 when the angle is minus 180. Okay, and once you know the cos of theta 2, then we know from trigonometry that sine squared theta plus cos squared theta is 1. So if you know cos theta, okay, so you will write it 1 minus cos squared theta, and sine theta will be equal to this. That's what you see here. But there is a plus and minus possible because of this square, because of the square root. Okay, plus minus. Okay, so let's say you have this 9 square equal to 81. Okay, x square equal to 81. Then x is 81 square root. So we have to put plus and minus because it could be plus 9, that still gives you 81. It could be minus 9 and still gives you 81. So we have two possible values of theta, okay, from the sine. So it could be S2 could be 0, okay, if you put from here 1. If you put from here 1, then S2 will be 0. That means theta 2 is either 0, that's why its sine is 0, or theta 2 is pi. Okay. And if you want to find theta 2, then there is a function in MATLAB a tan 2, which just you give S2 and C2 and it will give you that. The problem with normal tangent is that if theta 1 is in this and you know these coordinates, let's say this is px and py, okay, and if I give you px and py, so you will say that, okay, Tangent theta 1 is py by px, perpendicular by base, and theta 1 is just tangent inverse of py over px. But the problem is if the same were here and p was minus and y was minus, the coordinates were just having two minus signs, then even theta 1 is now this. But if you ask the usual tangent inverse, then tangent inverse of minus py by minus px is the same as tangent inverse of px py by px. So you will find the theta value, but you will never find the quadrant in it is. These two will give you the same theta, and that will be this. So how can you find this theta? Normal tangent inverse function cannot give you, because it just cancels out the two minus signs, and it treats them as the first quadrant. In first quadrant, both are zero. Both are positive. So what to do is, which function to use? A tan 2. I'll show this in the lab, in MATLAB. Just give it py and px, and it will give you theta 1 in the right quadrant. Theta 1 with the right quadrant information. Okay, so in other words, you have cos of theta 2, you have sine of theta 2. Just give it in this function in MATLAB and get your theta 2. So we have solved for only one theta now, and that is theta 2. The two unknowns are still theta 1 and theta 3. So if you know theta 2, is it hard to solve for theta 1? Where can we get this from? Okay, so what we can do is, okay, you go back to what was given. PWX was given A1 C1 plus A2 cos of theta 1 plus theta 2, this. And PWY component, this was given an A1 S1 plus A2 sine of theta 1 and theta 2. Now we are just expanding it. A1 C1 plus A2 C cos of theta 1 plus theta 2 के expand करें. So we know that cos of theta 1 plus theta 2 will be cos of theta 1 cos of theta 2 minus sine of theta 1 sine of theta 2. In other words, C1 C2 minus S1 S2. The reason we are doing it, because we are going to now we know C2. C2 is now known. Okay, and similarly the second one, A1 S1 plus A2 S12. So S12 to expand करें, so sine of S12 is sine of theta 1 cos of theta 2 plus cos of theta 1 sine of theta 2. In other words, S1 C2 plus C1 S2. Okay, so bring it in here. S1 C2 plus C1 S2. And now if you have that information, then look at this. Take the C1 common. So you will get A1 here plus A2 C2 minus A2 S1 S2. And take S1 common here. So you'll be left with A1 plus A2 C2 plus A2 C1 S2. And why we are doing that? Because we are going to solve for theta 1. And it's only possible if we isolate theta 1 and cancel out everything else. So now what we do is we take the square of both sides and add them. PWX square plus PWY square. And on the right side, what we can do is square them and add them. So how we do that? Let's say this is S1, not S1. Let's say this is X. Okay, so xc1 minus a2 s1 s2, and down there is x s1 minus plus a2 c1 s2. So if you square both sides and add them, so you will get x c1 square, okay, and plus x s1 whole square minus a2 s1 s2. Okay, so sorry, we have to square and add them. So squaring and adding is like this. Squaring and adding is are we squaring and adding them? Yes, we do. Okay. Yeah. So we were doing right. So this was, let's say this is x. So c1x whole square plus s1x whole square. What it will give you? X square c1 square plus x square sine 1 square. Take x common. So c1 square plus s1 square, which is equal to 1. So sine theta 1 square plus sine theta 1 square plus cos theta 1 square will give you 1. So we'll be only left with x square. So this is your x square. I equate this to x. This is your x square. And the other two are, just take, this will be minus a2 s1 s2 whole square plus this a2 c1 s2 whole square. So will be a2 square sine 1 square sine 2 square plus a2 square c1 square s2 square. So take a2 square sine 2 square common, and we'll be left with s1 square plus c1 square, which is again 1. So you'll be left with this. Okay, so it's a lengthy algebra, but there's no other way. There's no other way. Okay, so now what to do? Why we're doing it? The reason we're doing it is now we have got this. Okay, and what else we can do is all right. Okay, so from this equation we can isolate C1. So take everything to the left. So it will be PWX plus A2 S1 S2 divided by this. Okay, and then from that further, okay, it will be C1 PWX plus S1 की value कहाँ से निकालें? S1 okay, they plugged in S1. Yeah, S1 is here. Sorry, S1 is here. So how did they get that? So PWX, so multiply both sides by this. Multiply both sides by this. So इससे क्या हो जाएगा? We'll get square root of that. Okay, anyway, yeah, we've done it, but let's see how did we reach there. PWX, this side is, what I ask everyone is to do this, and whoever shows me how this comes out, he'll get 2 points. So I'm doing it here, you do it there. इसके बगैर जाना नहीं है. Everybody, please, यहाँ तक हम पहुँचे. We got these equations. Okay. अगर यहाँ तक समझ नहीं आई तो प्लीज आस्क क्वेश्चन. इसके बाद we have to solve for theta 1. We have to solve for, it's just simple algebra. It's just simple algebra. Okay, so we reach here, but what we need, what it needs is C1 is in term of S1. So cos of theta 1 is unknown and sine of theta 1 is unknown as well. So that's why I put it in red font. If we know S1, we can plug it in here and we can find C1. Now where to find S1 from? S1 from. So S1 can be obtained from these equations. From this equation. How? Okay, S1 and this PWX. Okay. PW question? G. Anyone has a question? Okay. This one seems like okay. I'm just wondering.
हेलो सर.
हाँ.
सर ये A1 प्लस C2 दोनों साइड पे ऐड किया हुआ है.
ऐड नहीं किए हुए, मल्टीप्लाई किए हुए, देखें.
सॉरी मल्टीप्लाई किया हुआ है सर. फिर C2 की जगह ओरिजिनल वैल्यू पुट अप की है.
हाँ जी. तो यहाँ ये कहाँ से आ जाता है?
सर ये C2 की जगह ये वैल्यू तो नहीं है C2 की वैल्यू.
A2 S2. तो ये
सर ये C1 की वैल्यू प्लग इन की आई थिंक.
अच्छा अच्छा, ठीक है. गॉड, ठीक है ठीक है, थैंक यू. सो यहाँ पे इस इक्वेशन को लेके मल्टीप्लाई बोथ साइड्स बाय दिस. So when you multiply both sides by this, so you get this on the left side. यहाँ पे ये स्क्वायर हो जाता है because you're already multiplying it with this. ठीक है. And यहाँ पे आ जाता है A2 C1 S2 और C1 की जगह ये प्लग इन किया. और इसका करने का फायदा ये कि एवरीथिंग विल बी जस्ट इन टर्म ऑफ S1. वो C1 एलिमिनेट हो जाए. तो C1 एलिमिनेट इस तरह होगा कि ये वैल्यू उठा के इसमें प्लग इन करें ये, और आप ऑलरेडी इस चीज के साथ मल्टीप्लाई कर रहे हैं तो इट विल कैंसल आउट एनीवे. It will cancel out. So what will be left with? You are just left with this thing. Okay. Now you have an equation which is only in term of one unknown, S1, and you can easily solve for that just by rearranging. S1 will be equal to PWX this minus थोड़ा सा इसको rearrange करें ना, खोलें. A2 S2 PWX ये वाला पार्ट उधर चला गया, माइनस हो गया. S1 ये स्क्वायर में आ गए. ठीक है. और इसको थोड़ा सा कॉमन लिया है, S1 को कॉमन लिया है, इन दोनों से भी कॉमन लिया है. और यहाँ पे A2 S2 होल स्क्वायर, A2 स्क्वायर S2 स्क्वायर. तो इससे S1 आ जाएगा. एंड नाउ यू प्लग इन दैट S1 इन हियर एंड देन यू विल गेट C1. तो थोड़ा सा लेंथी है, but it's algebra, so we are solving it algebraically. So now, where is your theta 1? Where was your theta 2? Theta 2 was here. We solved for theta 2. Okay. And okay. And once S1, sine of theta 1 and sine of theta cos of theta 1 are known, then plug it in the A tan2 function, okay, and you will get theta 1. And once you have theta 2 known, theta 1 known, then just plug it in the pi equation because pi was the sum of three thetas. Now this is known, You have found theta 1, you have found theta 2, so theta 3 can be solved for. So theta 3 is just phi minus theta 1 minus theta 2, this one. So you have solved for the three thetas. Okay. It's a lengthy equation, but algebraically we just played with the algebra. Next solution is geometric. So again, the given is the same. Okay. And this is given, I explained it. Now again we apply the cosine theorem to this. एक मिनट, इधर भी लॉ ऑफ कोसाइन अप्लाई किया था. अच्छा, आई एम सॉरी, ये जो हम कर रहे थे ये जियोमेट्री के थ्रू कर रहे थे, बट ये एक और तरीके से भी आता है. एनीवन? ये इन इक्वेशन को अगर आप स्क्वायर करें दोनों साइड पे और ऐड कर लें तो आपके पास ये आता है. तो इधर ये लॉ ऑफ कोसाइन से नहीं ले आए, मैं मिक्सअप कर गया. ये इक्वेशन यहाँ पे इक्वेशन को स्क्वायर और सम करने से आया, विच इज अलजेब्रा नॉट जियोमेट्री. जियोमेट्री में you go and look at the geometric shape and apply some trigonometric rules. But in algebra, you don't look at the diagram and you just do something with the equation. So px square plus py square is a1 square plus c1 square plus a1 square s1 square से ये आ जाता है प्लस 2 इसको एक्सपेंड किया है. ठीक है, तो ये मैं कर जियोमेट्रिकली कर रहा हूँ. मैंने ट्रायंगल से ये लॉ ऑफ कोसाइन अप्लाई करके ये लिया है, बट इट इज एक्चुअली इट शुड बी डन इक्वेशन 2 एंड इक्वेशन 3. सो लेफ्ट साइड पे आपके पास आ जाएगा पी एक्स स्क्वायर पी डब्ल्यू स्क्वायर प्लस पी डब्ल्यू वाई स्क्वायर प्लस इधर आ जाएगा ए वन स्क्वायर सी वन स्क्वायर प्लस ए वन स्क्वायर एस वन स्क्वायर. सो साइन ऑफ थीटा वन एंड स्क्वायर प्लस कॉस थीटा वन. ये मैं कर लेता हूँ. अलजेब्रिक कैसे आएगा ये? Okay. So what we have is P Wx A1 C1 plus A2 C1 2. Okay. Then PWY A1 S1 plus A2 S1 2. 2 and 3. So sum and square and sum. Both sides of the equation. What we'll get on the left side is PWX square plus PWY square. And on the right side of the equation, we'll get A1 C1 square plus A2 S1 square plus A2 C1 2 square plus A2 S1 2. Without looking at the diagram, we're just doing it algebraically. ठीक है, चीज वही आएगी.
सर A1 S1 नहीं है, A1 है सर, A1 S1 स्क्वायर.
हाँ ये थैंक यू. अच्छा, अब इसको खोलें तो लेफ्ट साइड विल बी दैट A1 स्क्वायर, डायरेक्ट ले लेता हूँ C1 स्क्वायर और दूसरा S1 स्क्वायर कॉमन ले लिया, तो इधर भी यही सीन है. A2 स्क्वायर cos of theta 1 plus theta 2 से क्या आएगा? C1 C2 माइनस ये A2 स्क्वायर को सबसे बाहर में रखें, A2 स्क्वायर और अंदर एक्सपेंड कर लें. C1 C2 माइनस S1 S2 प्लस S1 C2 plus S2 C1 साइन ऑफ थीटा 1 ये बता चुका हूँ कि भाई साइन ऑफ थीटा 1 प्लस थीटा 2 साइन थीटा 1 कॉस थीटा 2 के बराबर है प्लस कॉस थीटा 1 साइन थीटा। यहाँ पे मैंने शॉर्ट हैंड में लिखा है, ठीक है। तो अल्टीमेटली इन दोनों से तो 1 आ जाएगा, तो इट विल बी a1 स्क्वायर प्लस, अब इसमें कुछ कैंसिल होता है कि नहीं, c1 c2 माइनस s1 s2। ऐसा मुझे लगता है इसको स्क्वायर बी करना था, तो ये थोड़ा सा हमने मतलब इसको बी स्क्वायर करना था। ऊपर देखें ना, इधर स्क्वायर है और इधर इसको भी स्क्वायर करना था और a2 सबसे कॉमन निकल गया, ठीक है। अब a2 को उधर ही रहने दें, इसको खोल दें, तो c1 c2 होल स्क्वायर प्लस s1 s2 होल स्क्वायर माइनस 2 c1 c2 s1 s2, ओके, प्लस s1 c2 होल स्क्वायर प्लस s2 c1 होल स्क्वायर प्लस 2 c1 c2 s1 s2, ओके। तो ये तो कट जाता है, a1 स्क्वायर प्लस a2 स्क्वायर। अब अंदर क्या माहौल बनता है, c1 स्क्वायर c2 स्क्वायर प्लस s1 स्क्वायर s2 स्क्वायर प्लस s1 स्क्वायर c2 स्क्वायर प्लस s2 स्क्वायर c1 स्क्वायर। अगर जरा दे तो तुमने को, हाँ, everyone please be attentive. Okay, so we take, can we take anything common here? No.
C1 कॉमन तो
जी?
C2
C1
स्क्वायर प्लस सर C1 स्क्वायर कॉमन करे तो C2 स्क्वायर प्लस S2 स्क्वायर से 1 बन जाएगा।
अच्छा,
और
c1, यस, c1 स्क्वायर कॉमन लें तो
C2
इधर
स्क्वायर
c1 स्क्वायर है और इधर
प्लस
c1, ठीक है।
यस
तो इन दोनों में अंदर रह जाएगा c2 स्क्वायर प्लस s2 स्क्वायर और इन दोनों से कॉमन लें
S1 S1 स्क्वायर से
s1 स्क्वायर, तो रह जाएगा s2 स्क्वायर प्लस c2 स्क्वायर। तो ये इससे 1 आ जाएगा
और C1 स्क्वायर प्लस S1
और
से फिर 1 आता है।
उससे फिर 1 आता है। नहीं नहीं, कहीं ना कहीं ये एक सी ये एक C2, ये एक C2 आना चाहिए ना, नीचे देखें एक C2 आया है कि नहीं।
सर इधर S2 है, S1 नहीं है, तो S1 नहीं कॉमन है इसमें।
अच्छा, S1 कॉमन नहीं ले सकते।
Yes,
अच्छा, वैसे वो हमारा 2a1 और a2 किधर गया यार।
S1 सर कॉमन ले सकते हैं यहाँ पर।
अच्छा, नहीं कॉमन तो ले सकते हैं, लेकिन ये हमारे पास राइट साइड पे ये क्यों नहीं आ रहा, ये 2a1 a2। टू a1 a2 2a1 a2 कहीं
सर ये
कुछ।
कैलकुलेशन दोबारा कर ले।
अच्छा, नहीं पता है क्या, ये हमने इधर भी एक गलती की है, इसको स्क्वायर करेंगे ऐसे और फिर नीचे के साथ ऐड करेंगे ना। हमने क्या किया, हमने पहले वाले को स्क्वायर किया, दूसरे वाले को स्क्वायर किया, तो ऐसा थोड़ी होता है। हमने क्या करना है, इस पूरे को स्क्वायर करना है,
Yes,
फिर
sir.
इसको ऐड करने है, इस पूरे के साथ स्क्वायर करना है। तो जब इसका स्क्वायर होगा तो क्या होगा, a1 स्क्वायर c1 स्क्वायर प्लस a2 स्क्वायर c1 2 स्क्वायर प्लस 2a1 a2 c1 c1। ये चीज अभी कैलकुलेशन में इसके लिए जगह रखनी है, प्लस 2a1 a2। अच्छा अभी थोड़ा सा ये लंबा पड़ता है, मैं इसको बल्कि हो गया, क्राउडेड हो गया। a1 a2 c1 c2 प्लस इसका भी एक बाय प्रोडक्ट निकलेगा, a1 स्क्वायर s1 स्क्वायर प्लस a2 स्क्वायर s12 स्क्वायर प्लस 2a1 a2 a2 s1 s12। तो इधर आ जाएगा 2a1 a2 s1 s12। तो वो बाकियों को तो अभी सिंप्लीफाई करना ही है, इन दोनों को भी सिंप्लीफाई करना है। तो उन दोनों को कैसे सिंप्लीफाई कर सकते हैं, तो इसको खोलना पड़ेगा। मैं सिर्फ इनको सिंप्लीफाई करने की कोशिश करता हूँ, क्योंकि वो दूसरे से शायद 1 1 आ रहा था। इससे 2a1 a2 c2 आता है कि नहीं आता। तो लेट्स सी 2a1 a2 c1 c1 c2 minus s1 s2 plus 2a1 a2 s1 into s1 c2 plus s2 c1। 2a1 a2 c1 c1 नहीं c1 square c2 minus c1 s1 s2 plus s1 square c2 plus c1 s2 square c1 s2 square। oh yeah नहीं plus c1 s1 s2 पूरी दी है बस। हाँ c1 s1 s2, let me look, c1 square c2 minus c1 s1 s2 plus s1 square c2 plus s1 c1 s2। so
C2 को सर कम होना।
2 को 2a1 a2, तो इधर इसमें और इसमें
C2 को सर कम।
c2 रह जाएगा, ठीक है, और ये दोनों
क्या सर?
कट जाएंगे, ठीक है। तो ये वो आपके पास आखिरी आता है जो हमारे पास पहले नहीं आ रहा था। ये पार्ट निकाल लिया हमने ये, और वो जो बाकी हम सिंप्लीफिकेशन कर रहे थे ना इसकी,
वो ऑलरेडी 1 है।
वो ऑलरेडी 1 आ रहा था, वी वर ऑलमोस्ट गेटिंग देयर, लेकिन वो बीच में हमने वापस आया। तो कहने का मेरा मतलब ये है कि भाई थोड़ी सी अगर आप इसको कैरी ऑन करें तो अल्टीमेटली यू विल गेट दिस। और फिर इसके आगे कहानी तो हमने भी कर ली कि भाई अलजेब्री के लिए इसको इसी तरह रीअरेंज करके अल्टीमेटली वी हैव टू सॉल्व फॉर θ1 एंड θ3 θ2 एंड θ3। और जियोमेट्रिकली जो है, जियोमेट्रिकली इधर आपने, ये मैंने लिखा है बड़ा बड़ा, उधर ये नहीं लिखना था, कि इधर आप वो ट्राइंगुलेशन के थ्रू, ट्राइंगल्स के थ्रू ये चीज निकालेंगे। विच ट्राइंगल? दिस ट्राइंगल। तो इससे भी आपके पास ये आता है जो कि एग्जैक्टली वहां अलजेब्रिक के लिए भी आ रहा था। तो यहाँ पे लॉ ऑफ कोसाइन अप्लाई किया, ठीक है, और हमें ये मिला, और वहां पे हमने प्योर अलजेब्रा के थ्रू हम उस सोल्यूशन तक पहुंच गए। तो इधर कोई नई बात, θ2 इनका कॉज इनवर्स c2 आता है, उधर भी थीटा टू, वैसे हम इससे भी डायरेक्ट निकाल सकते थे, देखें ना इधर कोई भी और अननोन नहीं है, C2 यहाँ से थीटा टू डायरेक्ट भी यहाँ से निकलता है, ठीक है। लेकिन उसका मसला ये होता है कि कॉस थीटा जो होता है वो थीटा का साइन एब्जॉर्ब कर लेता है। कॉज ऑफ थीटा, कॉज ऑफ 45 भी जो आता है वो पॉजिटिव है, कॉज ऑफ नेगेटिव 45 भी पॉजिटिव है। तो जब कॉज थीटा को खा जाता है साइन को, तो आप थीटा कभी भी कॉज इनवर्स से नहीं निकालेंगे, क्योंकि आपके पास थीटा का साइन रिकवर नहीं होगा। तो इसलिए आई रिकमेंड यूजिंग a tan2 फंक्शन। मॉडर्न कैलकुलेटर्स में भी होता है और ये मैटलैब में भी है, ठीक है। ये क्वाड्रेंट अवेयर थीटा आपको देता है कि भाई ये थीटा की ये वैल्यू तो है, लेकिन किस क्वाड्रेंट में है, मतलब किस साइन के साथ है, ठीक है। तो यहाँ पे कॉज इनवर्स से उसको निकाला है, तो फिर इसीलिए हम आगे प्लस माइनस डालते हैं, क्योंकि हमें नहीं पता कि कॉज जो एंगल था जिसका हमने कॉज थीटा टू लिया था उसके पास प्लस था या माइनस था। वी हैव टू कंसिडर बोथ केसेस। इन वन केस इट विल बी एल्बो अप पोस्चर थीटा टू। देखें थीटा टू की ये पॉसिबिलिटीज हैं। अगर थीटा पॉजिटिव हो थीटा टू, तो जो आपको थीटा मिला है वो ये है पॉजिटिव पे काउंटर क्लॉकवाइज, ये पॉजिटिव साइन आपने पिक किया। लेकिन अगर आपको यहां से माइनस वाला मिलता है, तो फिर ये वाला जो थीटा टू है ये क्लॉकवाइज है, ये नेगेटिव। दोनों आपको वही ओरिएंटेशन देते हैं, वही डिजायर्ड पोज और ओरिएंटेशन देते हैं, डिजायर्ड पोजीशन एंड ओरिएंटेशन, चाहे आप थीटा वन को पॉजिटिव लें थीटा वन को नेगेटिव लें। तो मैथमेटिकली भी दोनों सॉल्यूशंस हैं, लेकिन एक को हम एल्बो अप पोस्चर कहते हैं। एल्बो अप, आप ये समझे ये आपका एल्बो है तो एल्बो ऊपर की तरफ, ठीक है। नहीं, एल्बो अप मीन एल्बो ऊपर रह गया, आपने हाथ को नीचे घुमाया। और एल्बो डाउन, एल्बो डाउन ये है कि थीटा आपका 0 से पाई तक हो, ठीक है। तो ये एल्बो है, एल्बो डाउन है, एल्बो अप है। हाथ को देखें ना, आपका हाथ ऐसे भी हो सकता है एल्बो डाउन, और आपका हाथ ऐसे भी हो सकता है एल्बो एल्बो डाउन, और वो हमारा एल्बो अप है, ठीक है। तो ये थीटा के दो सॉल्यूशंस हैं ये मैथमेटिकल प्रोसीजर के तौर से। अच्छा, बाकी थीटास को कैसे निकालेंगे? बाकी थीटास को तो वो भी ज़रा ट्रायंगुलेशन करनी पड़ेगी फर्दर। अभी बाकी थीटास हमारे पास नहीं आई। उसके लिए क्या करें, फिर से इस फिगर पे गौर करें। इस वक्त हमें फाइंड करना है थीटा वन, ठीक है। सॉरी, तो एक एंगल है अल्फा। अल्फा इज ये वाला एंगल आप कहां से निकाल सकते हैं? ये वाला एंगल आप सिंपली फिर इसका इस ट्रायंगल को आप देखते हैं, बाकी सब कुछ इग्नोर करें। तो दिस डिस्टेंस इज PWY and this distance, horizontal distance is PWX। ये नोन है, ये न्यूमेरिकल वैल्यू जिसकी नोन है, इससे हम अल्फा निकाल लेंगे। अल्फा a tan2 PWX और PWY, y x कंपोनेंट और y कंपोनेंट, ठीक है। अगर अल्फा आ गया तो फिर एक और एंगल है हमारे पास बीटा। बीटा इज, डायग्राम से देखें, बीटा इज अल्फा माइनस थीटा वन। बीटा इज अल्फा, अल्फा ये सारा है और थीटा ये छोटा है, अल्फा माइनस थीटा वन, ठीक है। क्वेश्चन? अच्छा, मून्स टाइम बस सब्र करें, भी जमात वैसी भी हो गई है, अलग से पढ़ना है तो अलग वाइंड अप इन 5 मिनट्स इंशाल्लाह, ठीक है। तो कॉस ऑफ बीटा जो है, अब बीटा बीटा का ट्रायंगल आप देख लें, बीटा वाले ट्रायंगल में हाँ जी, इस पे लॉ ऑफ कोसाइन यूज कर लें, बल्कि लॉ ऑफ कोसाइन नहीं, यस, ये वाला ट्रायंगल नहीं देखना, ये वाला ट्रायंगल है। इसमें बीटा निकालने के लिए हमारे पास एक बेस का होना ज़रूरी है, और बेस है A1 प्लस A2 C2, और परपेंडिकुलर जो है इसका वो ये है, वो आपको इससे भी मिल जाएगा, पी डब्ल्यू एक्स स्क्वायर प्लस पी डब्ल्यू वाई स्क्वायर। तो कॉस ऑफ बीटा जो है वो बराबर है बेस डिवाइडेड बाय हाइपोटेन्यूज, ये आपका हाइपोटेन्यूज और ये आपका बेस। तो इससे आप ये बीटा निकाल सकते हैं, विच इज एग्जैक्टली व्हाट हैज बीन डन हियर। और जब बीटा आपके पास निकल आए तो थीटा का हमने कहा था कि थीटा इज सिंपली अल्फा माइनस बीटा, अल्फा माइनस बीटा, ये एक सिचुएशन है। लेकिन अगर आप वो दूसरे सिचुएशन को देखते हैं, जब आपके पास थीटा 1, ठीक है, बीटा इज ईदर, अच्छा, तो थीटा 1 इज ईदर अल्फा माइनस बीटा, अल्फा माइनस बीटा। लेकिन अगर ये सिचुएशन है कि एल्बो डाउन पोजीशन है, तो फिर बीटा आपका ये हो जाएगा, ठीक है, नहीं ये नहीं हो जाएगा, बीटा आपका, बीटा इज ऑलवेज फ्रॉम दिस टू दिस, तो फिर थीटा आपका ये है, थीटा 1 इज अल्फा प्लस बीटा, एल्बो डाउन में, और एल्बो अप में थीटा 1 इज अल्फा माइनस बीटा, ठीक है। तो बीटा आपके पास यहां से आ जाता है, यहां से, एंड नाउ थीटा के दो पॉसिबिलिटीज है, डिपेंड करता है कि थीटा 2 आपने पॉजिटिव लिया है कि नेगेटिव लिया है। अगर पॉजिटिव लिया है तो थीटा 1 इज सिंपली अल्फा माइनस बीटा, और अगर थीटा 2 आपने नेगेटिव लिया है तो थीटा 1 इज अल्फा प्लस बीटा। और जब ये थीटा 1 आपके पास आ जाए, पिछले स्लाइड पे थीटा 2 आ गया था, तो थीटा 3 इज जस्ट सिंपली 5 माइनस थीटा 1 माइनस थीटा। तो इसको समराइज करते हैं कि अभी तक हमने क्या किया। इस पे एक एग्जांपल भी हम कर लेंगे न्यूमेरिकल वैल्यूज लेके, मैटलैब में भी इसको इम्प्लीमेंट किया जा सकता है बिकॉज कैलकुलेशंस आर लेंथी। एग्जाम के लिए ये तो मैंने 3 डिग्री ऑफ फ्रीडम आर्म लिया था, you can take 2 degrees of freedom on 2 degrees of freedom में you just get rid of this। ये बाकी दो चाहे अलजेब्रिकली आपको सॉल्व करने का कहा जाए, चाहे ज्योमेट्रिकली आपको सॉल्व करने का कहा जाए, ठीक है। इसका फायदा क्या होगा, ये 2 लिंक पे हम क्यों इतना टाइम गुजार, किसी भी आर्म में ये 2 लिंक का पार्ट मस्ट होता है, जरूरी नहीं है वो प्लेन पे हो, मतलब एक्स वाई प्लेन में हो सकता है, वो एक्स जी प्लेन में हो सकता है, वो वाई जी प्लेन में। इवन प्यूमा आर्म में भी दो लिंक हैं जो आपस में इस तरह उनकी ज्योमेट्री है। इवन आपको जो होमवर्क 1 असाइनमेंट दिया है उसमें भी ये चीजें अप्लाई होती हैं। किसी भी कॉम्प्लेक्स आर्म में आपको दो सेगमेंट्स हमेशा मिलेंगे जिनकी जीज पैरेलल है। इवन हमारा माइक्रोबॉट फर्स्ट एग्जांपल, उसमें भी कुछ लिंक्स के जॉइंट्स के जीज पैरेलल हैं। जब जीज पैरेलल हो तो यू गेट द सिमिलर प्रॉब्लम। तो इसलिए ये जो मैथ आप इधर प्रैक्टिस कर रहे हैं, इट हेल्प्स इन ऑलमोस्ट सॉल्विंग एनी काइंड ऑफ इनवर्स काइनेमेटिक्स प्रॉब्लम, चाहे वो आप काइनेमेटिकली ज्योमेट्रिकली सॉल्व करें, चाहे वो आप algebraically solve करें। But do practice this math. It's doable by hand. इसमें आपको मैथलेब की इससे ज़रूरत नहीं है। इसमें सबसे ज़्यादा इम्पोर्टेंट ये है कि ये मल्टीपल सॉल्यूशंस कैसे आते हैं। लेकिन थीटा 2 का ये भी सॉल्यूशन पॉसिबल है, ये भी सॉल्यूशन पॉसिबल है। और जब थीटा 2 के दो सॉल्यूशन पॉसिबल हैं तो फिर थीटा 1 तो थीटा 2 से ही निकलता है ना, ठीक है। तो थीटा 1 में भी फिर आप इधर थीटा 2 प्लग इन करेंगे। देखें बीटा डिपेंड करता है कॉस थीटा 2 पे और अल्फा थीटा 1 डिपेंड करता है बीटा पे। तो अगर बीटा में थीटा 2 की वैल्यू यहां से प्लग इन करेंगे तो फिर आपके पास दो ऑप्शन होंगे कि भाई यहां से वैल्यू प्लग इन करें कि यहां से। तो इसके करस्पॉन्डिंग थीटा 1 की एक वैल्यू निकलेगी, इसके करस्पॉन्डिंग थीटा 1 की दूसरी वैल्यू निकलेगी, बिकॉज थीटा 1 इज ईदर अल्फा प्लस बीटा और अल्फा माइनस बीटा। तो ये मल्टीपल सॉल्यूशंस इस वजह से आते हैं कि आर्म रिडंडेंट है। रिडंडेंट मीन आप जो इंडिपेंडेंट क्वांटिटीज हैं वो तीन है, पी एक्स पी वाई एंड दिस, और जॉइंट्स आपके पास तीन है। आप दो जॉइंट से भी ये अचीव कर सकते हैं, इवन एक जॉइंट से भी ये अचीव कर सकते थे। एक जॉइंट लंबा इतनी लेंथ का A1 प्लस A2 A3, वो आप ये अचीव कर सकते थे। इन दो एक्स्ट्रा जॉइंट्स की जरूरत ही नहीं थी, लेकिन जानबूझ के हमने उसमें रिडंडेंट थीटास डाले हैं, ठीक है, ताकि आप मल्टीपल सॉल्यूशंस देख सकें। मल्टीपल सॉल्यूशन इनवर्स काइनेमेटिक्स में एक सीरियस फिनोमेना है कि भाई अगर एक आर्म को मैं कहता हूँ यहाँ जाओ तो वो इस तरीके से भी उधर पहुंच सकता है और उस तरीके से भी पहुंच सकता है। Which one to choose? So we'll discuss that in next lecture. I hope you have got the basic understanding of this. If still not, then please try it by yourself and if you have any question, we can discuss in next lecture. किताब में भी इसी तरह डिटेल में गिवन है, तो अगर आप किताब भी पढ़ना चाहें तो मोस्ट वेलकम। बट किसी भी किताब को उठाएंगे तो ये दो तरीके बड़े कॉमन है, ज्योमेट्रिक सॉल्यूशन एंड अलजेब्रिक सॉल्यूशन, एंड देयर इज नो शॉर्टकट, इसके अलावा कोई तरीका नहीं। ठीक है जी, चलें भी अटेंडेंस ले लेते हैं।